Hello security gurus, welcome to this new lecture. In this lecture we are going to talk about insufficient binary protections, which is the category in OWASP Mobile Top 10 2023. So let's jump into the action. Let's first understand what is insufficient binary protection. Insufficient binary protection in a mobile application refers to the lack of security measures that safeguards the app's binary code from reverse engineering, tampering, or other malicious activities. Hence, it means that if app's binary code can be reversed, then it's an example of insufficient binary protection in a mobile application. Let's see what is the impact on mobile application. There can be theft of intellectual property because applications source code will be the company's or organization's property. If a hacker is able to reverse engineer the source code of mobile application, then it will result in theft of intellectual property. Second would be hacker can modify the code of mobile application and can release a modified version of mobile application. This will be another implication of insufficient binary protection in mobile application. Let's see what factors would indicate that your mobile application is vulnerable to insufficient binary protection. First is if you are not using any code obfuscation technique, then it means you have insufficient binary protection in your mobile application. Obfuscation is the technique of making your code unreadable to the hackers or malicious actors. So using code obfuscation is recommended. If there is no code obfuscation, then there is an issue. Second will be no mobile app signing. If you are not signing your mobile app, then this will also lead to insufficient binary protection. Mobile app signing helps to establish the identity of the owner of mobile app. So it is always recommended that before releasing a mobile app, you sign it with your cryptographic key, which will identify that you are the correct owner of the mobile application. Now let's see what are the mitigation steps that can help us to mitigate insufficient binary protection. First would be to follow secure binary practices. Let's see what are the recommendations. Use of obfuscation tools to prevent reverse engineering attacks. It means your code should be unreadable to hackers, and this will help to prevent reverse engineering attacks. You should sign your app, and also you should implement strong server certificate checks to prevent counterfeit apps to communicate with the server. So if there is a counterfeit app, it should not be able to communicate with your backend server because of strong server certificate checks. So it's recommended that you sign your app in order to establish the correct identity of the owner of the app. And secondly, there should be strong server certificate checks to prevent counterfeit apps to communicate with the server. And finally, you should implement integrity checks on startup to detect any modification of app binaries. So, for example, if your mobile application code has been modified, you should implement a mechanism to identify that if there is any modification of app binary, and if there is a modification, your app should not start. And you need to perform this integrity check on the mobile application startup. Hence, it's very important that you obfuscate, you perform app signing, you detect any modification in your application code, and stop your application from launch in case there are any modifications of the app binaries. All these mechanisms clubbed together will help you to safeguard your binaries and will help to mitigate insufficient binary protection issue. I hope you are now clear what is insufficient binary protection. I hope you have enjoyed this lecture. Thanks for watching. See you in the next lecture.